to.
The drop dates are earlier.
Yeah.
Yeah, they're earlier. They're like a week and a half now earlier. You have to drop, your W is now at like week 7 or 8.
Really, I heard it was the census date. W.
Yeah.
February 12th to drop without a W. Last day to drop with a W is April 15th.
But if you compare that to UC or CSU, that is still very generous. You still have a lot of time to evaluate the class and determine whether you want to drop the class or not. All right, well, let's get back into our usual stuff. The basic input, output, standard in, standard out homework is due. It was just due about 10, 11, 12 minutes ago. And this is really just a little warm-up exercise, for the most part, so that people get used to the environment, know how to get started with a virtual machine, how to transfer files, how to turn in files, and stuff like that. It is by no means intended to be a real programming exercise, related to systems programming. So the first thing I'll do is I'll just go ahead and disclose the solution to this homework assignment, and I'll just kind of describe, how I would approach the problem. So I'm just going to go to my folder created for today and read the assignment myself. To start with this homework assignment, you should read the man pages of read and write. So that should be the first thing people should do in order to do this homework assignment. We did that in the class too. I kind of went through the man pages and went through a few lines. There are multiple man pages for this, so you have to use this particular command to go to chapter 2 for that particular read topic. The only information that is missing from the man page is that if FD is the file FD is the file descriptor, and I explained here that standard in is file descriptor 0, standard out is file descriptor 1, and you can redirect in the shell command. Your task is to create a subfolder inside the cisp453 folder of your user account. Do all the work in standard in out. All right, so we'll go ahead and just create the structure here. So pretending that this folder here is my home folder, it really is not, but I want to pretend that it is my home folder. So I would first create a folder called cisp453, and then inside cisp453, I will create another folder called standard in out, and then inside that standard in out folder, I will create my program. So I'll say vi standard in out.c. Wrong class, never mind. I could do that in assembly too. All right. Your standard in out.c program should perform a simple task: echo everything from standard in to standard out, exit when end of file of standard in is encountered. You may assume there are no errors to handle. In other words, just assume you have a valid file to input and you have a place to output if you want to.
What errors would we get from that if we're redirecting standard in to standard out?
You can potentially run out of space when you write. If you redirect to an output file and the file system is full, or it may not be able to do it.
Or permissions.
So you can still potentially run into problems.
Permissions too. If you don't have permission to write.
I'm not sure the permission thing. Well, that would happen when you try to open the file. But by the time it gets into your program with standard in and out already open, I don't think you'll run into permission problems.
Well, someone always could chmod it outside, like if
while you are writing.
while you're doing it.
Yeah, that can happen too. Yep, you're right. Okay, so exit when end of file is encountered. You may assume there are no errors to handle. Blah blah blah. I suggest that you use a loop and use and read standard in byte by byte. It's only a suggestion. If anyone wants to abuse recursion, the whole program can be done recursively.
Can it be done in an array, considering that you don't have unlimited? I mean, like you may have limited output or input in a terminal, but you don't have limited output in a file. I mean, you can't really count for how many characters are.
It makes it harder. It really makes it harder if you do it that way. By the way,
it is possible though. It is possible though.
It's possible
to do it with an array of characters.
Well, if you do it with an array of characters, you have to really pay attention to how many bytes you read, because But if you make it a one single character buffer, it just simplifies your logic a whole lot. All right. Yep. Go ahead.
So, am I understanding the read function correctly, that it will essentially your program will block until it has something to read and will
That is
rise.
correct.
Okay.
That part depends on how the file was opened, but since I did not say anything about open, the default behavior is read will block when the input file is still getting its content. It's not only when you're reading from the keyboard that it can be blocked. If you're reading from, let's say, a network card or some other stream, it is possible that your program is running faster than the pipe gets filled. So there are times that your read subroutine will say, oh, okay, I got nothing else to read, and it would just go to sleep. The process is actually going to sleep until there's content in the pipe, and then you can start to read again. Okay. All right, so we have to include unistd.h. So we'll go ahead and do that. Oh, I used the wrong window. Where's here? Okay. All right, and then we have to use the main function. All right. Now I don't want to actually just go ahead and read read the man pages for read and write, so I'm just going to assume that you have read that part already. I'll declare a local variable called count, and I always just make sure that I terminate the subroutine correctly, so I'm just going to stick in the return 0 at the end here. All right, the best way to do this is actually to do it is, there are several ways to do it. I would do it as a do-while loop. This is one of those rare cases where a post-checking loop makes more sense.
That's interesting. I never would have actually figured of doing it like that.
Well, it's one way to do it. I mean,
I'm not saying you're wrong. I'm just saying it's interesting. I didn't think of doing it like that.
Doing while count is not equal to 0?
So yeah, that's what I thought.
while count is not 0. That's right. And then inside here, I can have a local, character. Single character is fine, and I'll pass the address of that local variable to read, and I'm telling read to read one single character. Now I have to be careful here because I cannot just say write right away, because if it read back nothing, then there's nothing for me to write. So I have to say if count is greater than 0, then go ahead and write that character back. So I say write 1, basically the same parameters, like that. Yep.
Why not simply put the read in the while, use a while loop instead of a do while, and get rid of count entirely?
Yep. Well, okay. Let me show the. Okay, I know what you're saying. So I will say void really unsize version. If I do this in assembly, I don't even need a local variable. It's kind of hard to avoid when you're using C though.
So that's how you get the size so small.
So what you're saying is while read 0 ch, the address of ch1, and just to do a little check here, because if it returns -1, I'd probably want to quit too. Write 1 ch1.
Oh, that is cool.
Yep.
So yes, you can do it this way. It's definitely fine. It's just that this is a little bit too concise. It doesn't really spell out how it works, whereas the other one spells out everything. It's for the discussion of a class. The second version, even though it's a lot more verbose, it explains how things are done. The first one is good because you're basically lumping a lot of stuff as concisely as possible. Yep.
Okay, I read the man page on both read and write, and you're passing an address of a character into something that's supposed to be a void pointer.
Yes.
That actually works. So
Yes.
it casts. It'll recast that pointer as a void.
Yes.
Oh.
Yeah, the compiler can automatically cast any pointer into a void pointer without an explicit cast.
So
because
it works
you're
both
losing.
ways then.
It only works one way
Oh.
because you're losing information. let's say it was, in this case, it's a char pointer to begin with.
Yeah.
But once you turn it into a void pointer, the type information is lost. It's always okay to lose information when you're casting. But when you're casting, you're gaining information. That requires an explicit, cast, because you have to tell the compiler it is okay to treat this blah 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 pointer as something else. Okay, but in this case, I'm just losing information, and there's no problem with that.
Okay.
Okay, so we'll go ahead and test the program. Okay, gcc-o standard in out .c.
Why do you not just use GCC and then the standard out C? I mean, this is the same thing, right?
Yeah. What do you mean?
It'll compile it and
SA.out?
Yeah, it'll compile.
I just don't like the name A.out. That's why.
Okay.
Okay. So the first thing I would do is just to test it, using standard input from the keyboard. Okay, this is a test. It echoes back. This is a test. Control D. It exits. It's all good. Next thing I want to test it would be for the boundary conditions. Boundary conditions like an empty file. Okay. Well, I can kind of give it an empty file using this using the keyboard. I just type Control D right away, but I can't really quite tell whether it is behaving correctly, because one programming logic error that people make in this type of program is they write regardless of whether something was read. Okay, so they will still output one single byte to the output file, even though the input file is empty. So to test that, I have to create an empty file. So this will create an empty file called empty.txt. Then I can run the program, redirecting empty.txt as the input, and I will just redirect the output to output.txt. So this way, I don't have to read the screen to find out what is the content of the output file, because I can examine the content of the output file later on.
I have a question.
Yep.
What's the less than symbol do?
The less than symbol redirects the standard in from a file. The greater than redirects the output to a file.
So
standard out to a file.
It's the opposite of a pipe.
No, it is the same.
Oh.
It's not. There's no piping here. Pipe implies that you are using the output of a program to serve as the input of another program. Redirection is just saying, okay, take this file and use this file as standard in. Or when you want to output something, capture that in that output file.
So if you were to do like cat file, then that it'd do the same thing with a pipe.
Exactly.
Right?
We're basically re-implementing cat. Yes.
Okay.
Okay. So is that okay so far? Okay. So that's basically what this program was. It was a very simple homework assignment. It was not intended to even be a little bit difficult. Yep.
Sorry, just real quick. Now you did output.txt so that you would go examine that file and what you would see a garbage byte if you were not checking for write.
Well, in this case, I can check that it is actually empty.
Oh, okay. Just by looking at that, that's why you did
right.
that. Okay, I got it.
Because if a program outputs a null byte, a byte of 0, I cannot see it on the screen.
Right.
But when I do it this way,
Check the
it will
size.
still have a size of 1. And then I can use hexdump to find out what that byte is.
That makes sense.
Well, it's incorrect to output a byte anyway, but I can go in and actually see what byte it is also if I wanted to.
I understand, but you're just checking the size with this.
That is correct.
So one more time, what does read do if it doesn't read anything?
What does
read return if it doesn't read anything?
it returns okay, read always returns how many bytes it has read by the time it returns. When you are at the end of a file, according to the read man page, it returns 0 because you cannot read anymore. There are no more bytes to read. So the request to read another byte from the file will just be returned with a 0 because the operating system is saying, I can read no more, so I just read 0 bytes, and that's the end of file indicator that you should be looking for. Okay. Any other questions about this program? Standard in out. Yep.
How did you get your demo one so small?
My demo one?
Yeah.
I think it's a program called strip. So let's try strip first. Strip, standard in out. It got it down a little bit. Let's try a compile option here. -03. And then strip, standard in out. actually bigger.
Is,
Well, Dash 03 actually makes it faster, but not necessarily smaller.
is the main reason for compiler optimization so someone can't decompile your code and then look at it?
No. The optimization is really for making the program going faster for the most part. What you're looking for is called an obfuscator. There are programs that can do that too. But the optimized output of a lot of programs, make it also more difficult to read. But that's a side effect. It's not an intended effect. It's just a side effect. All right. I don't remember how I could make it so tiny. Maybe I wrote it in assembly. I probably could, have done that, just as an exercise for myself.
I haven't looked at the grades, but so this assignment's graded and is in our grades now. Is that true?
It's not graded yet, so I haven't graded any homework assignment yet because I'm still setting up the infrastructure for grading. So I want to set up the script system. What I do is I will collect all the submissions that you guys turn in as one single big zip file. And then, once I download that zip file into my home machine, I'll just run the script that will, take the zip file, extract all the tar.gz files that you guys turn in, and then for each tar.gz file, it will also expand that, and then it will go into each subfolder, check, run the test, feed it an input, check the output, and also, pop up an editor so I can look at the source code. So it will do all of that stuff, semi-automatically. All right. Any other questions about this one?
Yeah, what editor are you going to use to look at her stuff?
VI.
Oh, okay.
What else? All right. So the next thing I would do is to give you guys a sample MBR because I think for your homework assignment, some people were finding it a little difficult without a sample MBR and knowing what should be the output for that particular sample MBR. So what I would do is I would include a sample MBR. Was one included in the zip file or the tar file? No? Okay. That's okay. We can do it pretty easily here. So I would change to root user and then do a, I probably should change my folder a little bit here. dd if equals /dev/sda, which is the first drive. That's the internal hard drive of this computer, which does include bootable partitions and stuff like that. of is my mbr.bin. I want a block size to be 512 bytes. In other words, it's exactly the length that you need in order to do your homework. Assignment, and count is 1, which means I'm only reading one single block. One block is 512 bytes. I'm reading only one block. Okay, and then I can. Yeah, I probably want to change the ownership here. There we go. So now we have an mbr.bin file. Oh, I forgot one thing. Okay, this part is going to be recorded, so when you want to find out what your program is supposed to output based on this particular MBR sample file, you have to kind of go back to this part and just kind of watch this part. Take a screenshot, stick it on your thumb drive, so you have it with you, in a convenient way. The program, and we have talked about this. We talked about this already. CFDisk is a program that will let you examine partitions and do all kinds of other stuff with a hard drive. And it's a nice program because it's interactive. So right now it's already telling me that we have only three used partitions. The fourth one is not used. Your program should output all 4 anyway. Okay. The first one is bootable, so this one should have hexadecimal 80 as the flag. You can also look at the size. This is relatively small as a 373 megabyte partition. The next one is big. It is a 24 gigabyte partition, and the last one is a 8 gigabyte partition. And then you have some free space left.
So 2 and 3 are not bootable.
2 and 3 are not bootable. Typically, in the partition table, only up to 1 partition should be bootable. You may have none bootable, but even if you want to make 1 bootable, there should be only up to 1 that is bootable. All right. So once we're here, we go to print.
So if you want to make it so you have 2 different bootable partitions, only one should show up as being bootable here?
You cannot make two partitions bootable. When you make a second partition bootable,
It's actually-
either it will give you a message and say one is already bootable and not let you change the other one to bootable, or it will change the other one to bootable but turn the first one to non-bootable automatically. Alright, so with this I can go to print and actually look at the content of the partition table, and this is these are details of the entire partition table. Each row is one partition record. Flags is whether it's bootable or not. This is the CHS portion. This is already interpreted. In other words, these are the exact numbers that you should be seeing when you run your program. The ID is something that you don't have to deal with. That's basically a partition type. Is it NTFS? Is it FAT32? Is it extension 2? We don't need to output that portion. The ending part, same way, you have to report the CHS, cylinder, head, and sector at the end of this particular partition. This is your LBA, start sector, and this is the size of the partition in numbers of sectors. So this is a really good, capture right here to show you what your program should be printing when you use it on this particular bin file. Any questions about this? Yep.
Do you happen to know whether it works correctly if you redirect a 512 byte file into CFDIS to print out it?
That's a good question. I don't know. I think it probably will bark and complain because I think CFDIS is smart enough to expect a block device. So if you pass a regular file, it knows it's not a block device, and it would just kind of go, no, I'm not going to do this. Yeah, you can try, CFDIS, mbr.bin. Yeah, bad primary partition 1. Partition begins after end of disk, because guess what? The disk only has 512 bytes. All right.
Could you go back and show that one more time?
This one?
The next screen.
This is what our program still stopped at.
How do we get
Similar. You are reformatting things to a different format according to what I described, but the same content should be there.
Do
Yep.
do you know if this is this decimal that we're seeing here? Is this hex?
These are decimal because if you look at the output, anything that is in hexadecimal has a prefix of 0x. So anything that does not have 0x as a prefix would be decimal.
Okay.
how do we get to that screen from the other screen?
You just click, select print,
Print.
and then press the enter key, and then select table, press the enter key again, and then enter the file name or press return to display on screen. Just press, and I'll just output the file name, so I will upload both the mbr.bin and also the output of that screen. How about that?
Nice.
That would be nice.
Thank you.
So I would call that partition table, partition.txt. All right, so now we can quit. And I forgot to change the ownership of that file. That's okay. I can still upload it. So now we can go to here. I will just go ahead and add a resource. So I'm just going to add these files individually so that you can just click that link and you can download that. So we'll go ahead and do this. mbr partition table.txt. I want to put it somewhere else. It's okay. Go to today's folder. We have the text file. Upload. Link. The font size is too big. I can't deal with it. Alright, choose. Save. That's the first one. And then there'll be one more. Now remember, this kind of stuff, you should be able to do as well. I'm just, making it easier for you guys. mbr.bin. Upload the file. There we go. So now for the homework assignment, you can now have a sample mbr.bin and also the interpreted content of that mbr.bin. And I would do even this. I'm going to move stuff around a little bit here and list everything under the right assignment, and then use indentation to help you locate it.
You're too kind.
So do you have your own program that you could run the output? You're feeling solid on the output of that?
Yes, because this is not a program that I wrote. This is not my program. CFDisk is a program that is provided by the system. So I'm 100% sure that the interpretation of the MBR is correct.
Right, that wasn't my issue. I was just wondering, when it dumps into the bin,
Well, how about we double check that? Okay, that's a good question. The question is, even though we know that part table.txt has to be correct because it is an output from CFDisk, we are not quite sure that mbr.bin is the actual mbr of that drive. Okay, so the consistency between these two files has not been established. So what we'll do is we'll take a look at mbr.bin, and I think last time we actually did that.
Yeah, using
last
hexdump.
time using exactly that particular bin file too.
Yeah, we did.
So you can actually just look at that. Well, we can do a quick one. We can do a quick look here. So I'll look at the PDF, and we'll just do one check. Okay, we'll check the number of what is the head count of the beginning part of this partition. That's the one thing we'll check. This is actually byte 2 or at offset 1 of the first entry of the partition table. And according to this, the first entry is at 446. So this should be at location 447 when I look at the hex dump of that file. So we'll go ahead and do a hex dump -c and mbr.bin. We are looking at we are looking at 446, which is 1BE, so the next location is 1BF. 1BF would be this byte here. Okay, it's 20 in hexadecimal, and 20 in hexadecimal is 2 times 16, which is 32 in decimal. So we switch back to this screen here, and we look at the output of that program. Oh, this is, I must have.
It was down at the bottom, I think, on that screen. That
Yeah, I think I had another window open
Got it.
at the time.
It was 32.
Yep, so 32. Now, by no means is this a full verification of the output, but it seems to be consistent.
So it's hex dump minus capital C.
To look at the content of the binary file. Alrighty. Now let's go ahead and move on. What were we doing last time? I cannot remember what I was working on. Let's take a look at the folder from last time. 0206. Okay, we were working on the read mbr.c program, and we were talking about stuff like conversions, base conversion, not base conversion. We did talk about base conversion a little bit here. I illustrated how to print hexadecimal numbers using your own subroutine. But since you are allowed to use printf, it depends on what you think. If you think that learning how to use printf or the formatting of printf can take more time than to write the subroutine to do it yourself, go ahead and write your own subroutine. If you already know how to use printf, go ahead and use printf. So you have full freedom to choose what you want to do in terms of generating the output. Okay. Any questions about that part? No questions about that part? All right. So the next thing I want to explain, which is not only useful for this homework assignment, but also useful for the next homework assignment, is how do we look at a few bytes and not look at those as individual bytes, but combine that into a constant. I kind of illustrated that here already by looking at this. You guys remember this part? I'm reading in the bytes one by one, but I'm outputting these 2 bytes combined as a 16-bit integer. And the trick, or the trickiest part of this, is to understand it is a little endian integer. In other words, the least significant byte is stored at a lower address. And that's why the byte at location 444 or index 444 in the array is the least significant byte, and then the byte at location 445 or the index 445 is the more significant byte. And then I explained how to use the bit shift operator and also the bitwise OR operator to combine the low half and the higher half of a 16-bit integer into one single 16-bit value. So I think that's where we stopped last time. Is that right?
Sounds right.
Okay. But there's actually another way to do this. The other way to, yeah, go ahead.
I just want to ask a quick homework question before we get too far away from it, which is, do we need to verify, other than the stuff you specifically stated, can we assume that the rest of the data is valid and not do any error check on it?
You are correct.
Okay.
Yep. So you don't have to report the portions that I asked you to report. The rest you don't have to check or report. Okay, very good. All right. So is this part okay? Let me give you a preview of your next homework assignment. And for people who want to get a head start, this is a good time to get a head start. The next homework assignment is raw extension 2 access. And you can see that last time I made this homework assignment, enough people could not turn it in on time that I have to start a second one for late submissions.
Yes.
So hopefully this time it will be a little bit better. And we'll go ahead and bump up the font size, and we'll take a look at the homework assignment. And now you can see it. It is not assigned yet. I'll go ahead and what I'll do is I will disable the available from date so that you can see it, and I'm going to disable the due date at this point, which means there's no due date, but you can see the homework assignment. You can actually turn it in if you want to, but there's no need to get started with it just yet. But you know what is coming.
It sounds ominous.
It really does.
You will find that as a common theme of classes that I teach.
That sounds even more ominous.
All right. Now, once again, this is, I don't even describe extension 2 because, it is well described and it is well documented elsewhere. So use this as a reference. It's a link to an HTML document. It's actually a document that I captured from, another source. So we'll go ahead and open it in a separate tab. It's not, I did not write this, somebody wrote it. And you will have to read a portion of this at least. Okay, not the entire thing, just a portion of that. And I'll guide you through the process too. So I'm not going to ask you to read the whole thing about, and learn everything about extension 2. I will pinpoint the stuff that you actually need to know. So getting back to the homework assignment. This assignment tracks down the first super block and also the root directory. The program that you write in this assignment also lists the directories and files in the root directory. As a quick summary, this spreadsheet in OpenOffice Calc format may be useful. So we'll open that up as a LibreOffice spreadsheet program, document. So
Will OpenOffice work on this?
OpenOffice should work with it too. Yeah. Okay. So we'll keep this one open, and then we'll keep reading in the homework assignment. Use a directory called root reader in cisp453 of the regular user home directory to contain all the files The program itself should be called rootReader.c. Okay, fairly standard stuff, just naming conventions. The program behavior should be like this. The program should accept one parameter, and that is the path to the file or block device that represents the extension to file system. If the program is invoked without any parameters, it should print the following message and exit. Okay, so we have a first hurdle now. How do we know whether when you ran the program, it has a parameter or not? Does anyone?
Yeah.
ArcC.
ArcC
And
will tell
string.
you the count, and then ArcV will
Yeah.
give you the actual parameters. Okay, so let's go ahead and just play with this a little bit first. And if anyone asks me later, how do I, check parameters and how do I access parameters? My answer will be watch the video of the 8th of February. Okay. So let's go back to today's folder, and we'll go ahead and write a program just for that. Okay. I'll just call it params.c. And I don't know. Should I use GDB to illustrate this, or should I use a printf? Hmm? Sorry?
Use right.
Use right. You're tempting me.
Or better yet, use expanded assembly in C.
All right, I'll just use standard out, for the time being. And well, the first part is really to illustrate when we use main before, we usually do it like this, but that's ignoring the parameters that are actually passed to the main function. The main function is passed two parameters more specifically. It is passed these two parameters. The first one is usually called argc, or argument count. The second one is called argv, argument, what is v? Value? Okay. And it's usually a const like this because you're not supposed to change them.
You can have a double pointer.
It's a pointer to a pointer.
Oh, that's interesting.
Well, okay, how many of you still remember, what is a pointer in C? How about an array in C? I should see the same number of hands, right? All right, so that means, you can also interpret this as an array of pointers. Each one is pointing to a character. It's an array of strings, if you will, okay? A string is an array of characters. This is an array of strings, okay? Well, there's not really a whole lot to begin with, so we'll just begin with something relatively simple like this. Printf argc equals %d \n for end of line, and we'll just go ahead and say, okay, what exactly is argc in this case? Because we want to test the program. Okay, gcc, this time I use -g because I want to retain debug information. -o params.c, and we have a program called params now. But params, even though it's executable, I can just do it like this. Okay, it's really, like that. And it tells me there are 6 arguments, or 6 parameters. And then people go like, attack, it's not right. I mean, we can see 1, 2, 3, 4, 5. Well, the command itself is actually also a parameter. It is parameter 0. So this is our parameter 0. This is parameter 1, 2, 3, 4, 5. And because we counted from 0, there are exactly 6 of them. Okay? But, but that means, if I want to check, the other stuff, I have to recompile the program, add more printfs, it's very, very troublesome. Well, that's not really the case because I have GDB. Okay? GDB is extremely helpful in this case because when you say GDB params, it allows you to debug the program. But there's really not much to debug. Well, if we are not debugging the program, at least we can print out argc and also argv in this case and see what they are, what they look like, and what is being pointed to by the pointers of argv or elements of argv. right? So we'll go ahead and put a breakpoint on line 5. It doesn't really matter where we put the breakpoint as long as it is somewhere in main. We run the program, it is about to print, do the printf statement. There's not really a whole lot to do here, except I can now say, tell me what is argc. Argc is 1. Does it make sense?
Yeah, because the file name you said was an argument.
It's just the program itself, right?
Program
the
itself is an
executable
argument.
itself. Well, if that is the case, what exactly is it? What is argv? Okay, now we have a problem. Because argv is not an integer for one thing, it is a pointer to a constant character. Okay? The good thing is GDB is actually pretty smart. Because when you use GDB to debug a C program, the debug information is actually maintained so that GDB actually understands what is the type of argv. So when you say print argv, you get this back, which is saying, it's just a pointer to constant characters. But that means you can also do something like this now, right? What exactly is the type of argv bracket 0?
It's the first element of the array.
It's the first element of the array, but what is the type of that element?
Yes.
It's a const char star.
Yeah.
It's a pointer to a const char, which means this is a string, okay? And GDB actually understands the concept of a string. It knows how to print out the content of a string like this. This is our first parameter. The first parameter is the full path to the executable itself. It works great. Do we have a second parameter in this case according to argc? Nope. That's because I did not run it with a second parameter. All right. Okay, that's good. So how do I test the additional parameters? How do I know that I can get the file name for sure as the second parameter? Well, when you run it inside GDB, you can also supply parameters when you run it inside GDB. So you can say run with mbr.bin. Okay. It doesn't even matter what file I give it. I can say bogus file. Okay. It doesn't even exist. All I'm checking here is this going to be a part of the arguments that I can access in the C subroutine, in the C program? That's what I'm checking right now. So I press the enter key, it will give me a warning and say, well, your debug session is not done yet. Are you sure you want to restart the program? And I'll go ahead and say, yes, I want to restart the program because I want to check argv, in this case bracket 1. But before we go that far, we'll have to take a look at argc first. What do you expect when I print argc?
2.
It should be 2 because now we have the program path itself and the parameter that I just specified. Now I can say print argv bracket 0 should not be changed from last time because the executable is still the same path, so that part has not changed. But now I can look at argv bracket 1 and it does say bogus file. So that's how you can, one, check whether you have the right number of parameters, and once you have the right number of parameters, you can access that particular parameter. Any questions? No questions? All right. So the first part of the homework assignment is done. Well, not done, but you know how to integrate this code into it. All right. And this part here is the point value. So this is 1 out of 20. 1 out of 20 points. The next thing you have to do is to open the file. Do we know how to open the file? Yep.
No.
Or is that 1 out of 20 supposed to be included in our error messages?
No, it's not. It's just, your error message goes from here to here and that's it. Good question.
Well, you changed your format on the second one, so it makes more sense. It's not included in the highlighting and it's bolded, so.
Yeah, I was sloppy. Get rid of the background color first.
You are too kind, Dr. Tech.
And change. Well, I just don't want excuses. There we go.
Thank you.
All right.
Otherwise, there might be no student success.
I think student success, should be defined as, 10 years later, where are those students?
Amen.
That would be a good measurement of student success. Yep. But that means, whoever is in office now, would no longer be in the office. They don't care. I mean, it's like 10 years later, it'll be somebody else's job. Okay, so next you have to use open to open the file. Now you have to open the raw file or block device in read-only mode, just so that, if you do anything dangerous, you're not going to write anything back, to the file. Open will return a file descriptor, which is an integer. Use that for all further access to the file. If the open operation fails, your program should exit with the following message: cannot open extension to file system raw file or block device path. Just use exactly that term here, copy and paste it, and you're done with this part of the program.
Should we return 1? Should we return 1?
No, I don't check the exit code anyway. So
But we should anyway, right?
Yeah, you should return the exit code to say that something is wrong. Yep.
Should we try and slightly gray out our terminal for the output?
Slightly gray out.
Use curses for that.
And use the bell character. Bing, bing.
Will you grade us down for that?
The bell character is Control G, by the way.
Yeah.
But if you're using printf, can't you just \A?
For the bell.
Yeah.
Or
Yeah.
backslash E, or something else.
Or you can do a \0 and then give it an auto code, of G. Yeah.
Or we can make it blank.
Or you can do escape sequences to xterm and Otherwise, the program exits after this point. Your program should close the file handle using the close call to find out how to use close. If you cannot open, you really cannot close anyway. All right. Are there any questions up to this point? Just opening the file. Now the seeking part is going to be the interesting part. From time to time, you need to jump to specific spot in the raw device, because this time you're not going to read the whole thing into memory and then do the processing at that point. You are going to use seek to go to the right portion of the file, read a few bytes, read a few 16 bytes, 32 bytes, whatever is convenient, but don't read like the whole device in, because there's no way you can fit your entire hard drive in memory. So the first thing you want to do is to check the validity of the super block. You have to check the magic number. Okay. How do we do that? What is the super block? That's where you have to start with reading this part here. Okay. Go to disk organization, and here we begin the fun of what is an extension to file system. All right. Before we go any further and talk about a specific file system, let me just talk about in general what exactly is a file system and how does it relate to stuff that we have talked about so far. Okay, we have talked about the partition table, right? And the partition table is the first sector of what? What is SDA? It's the entire hard drive. Okay, the entire hard drive is SDA. The partition table is the first sector of the entire hard drive. Is that okay so far?
I'm sorry, the partition table is?
The partition table, or the MBR, excuse me, the MBR is the first sector of the entire hard drive, and the partition table starts at location 446 of the MBR. Very good. Okay, thanks for the clarification. Next is what is a file system? Well, each partition is a, not in all cases, but as far as this class is concerned, we can simplify the view, and we'll just say that each partition is a file system. In other words, if we go back and look at the stuff that we captured already, let me just go back to that point. If we look at the file that I just captured, okay, partition table.txt, this is one file system. This is a partition, and in the partition is a file system. This is another partition, a much bigger one, and it is a file system. And this is also another partition, and it contains another file system. The last one is not a valid partition because you can see that it has no starting point, it has no ending point, and it has a size of 0. So it's, that partition does not exist. We only have 3 valid partitions in this case. In this case, the ID tells me that this is an NTFS file system. Okay. So what exactly is a file system? When you look at this, what is this telling you in terms of the organization of data? All it tells you is this is an NTFS file system. It starts at sector 2048. It ends with sector 529,088. Okay. That's just one big array of sectors. It doesn't tell you exactly how folders are organized. It doesn't tell you how files are stored. It doesn't tell you how a big file is stored across multiple sectors. There's nothing here that tells you how the file system or files and folders are organized within that file system. Are we doing okay so far? And that's what a file system is. A file system is basically a particular standard, a particular way of utilizing the sectors of a hard drive. And it gives you the pretense of files and folders and stuff like that. Because without a file system or without the correct interpretation of the sectors, all you can see is, oh, we have a whole lot of sectors, and that's it. This is an array. The first partition from this perspective is nothing more than an array of 729,088 sectors. That's all it is. It's a huge chunk of memory or storage in this case, but there's no organization.
So it's similar to a driver, right?
That is correct, because in Linux, in order to understand a particular file system, you have to load the correct module, which is actually kind of equivalent to a driver in Windows terms. Okay? Are we doing okay so far in terms of the concepts?
So the start sector, is that an address? What is that 204?
This is the sector. Okay, there are 2 ways to look at a hard drive. The first way to look at a hard drive is to look at its quote-unquote physical property. In terms of the physical property of a hard drive, you look at it as a hard drive is organized physically like this, right? You have platters, and then you have disk heads, 1 per platter, and then you can move the disk head to different tracks. On each track, there are multiple sectors. So that's why you have this CHS notation, which is determining what is the cylinder. The cylinder is basically all the tracks of all the platters. Okay, that's your cylinder. Head specifies which one of these multiple heads am I paying attention to, and then the sector tells me which part of the track is the sector that I'm referring to. So that's one way to refer to the beginning of a partition. But the more common way to specify the beginning of a partition is just to use the LBA notation, in which case you look at the entire hard drive as one huge array of sectors. It's all sequential. It is one single big, huge array. And that's an easier way to look at things, and that's why most modern drivers and file systems will only use the LBA notation, and the rest of it is really kind of artificial to begin with. Because if you plug in your SD card, guess what? The system will say that your SD card has cylinders, head, and sectors. But that's not true. It's not even a drive. It's not a physical drive. So how can we have cylinders when you have a solid-state disk? So that part is completely artificial now. Even with a physical hard drive, those numbers are really just fake numbers to begin with. Okay. Any questions at this point? So for the most part, we only use these numbers, the start sector of a particular file system, and also the size of that particular partition. Okay? So that means if I start at sector 2048, I can look at the file system as an array of 729,088 sectors. Yep.
So the bigger the bigger the partition, the more sectors it should take up, right?
That is correct. In other words, you can multiply the number of sectors here by 512 bytes that would be the size that will be the raw size of the partition allocated to that file system.
What do you mean raw?
Raw means you cannot really utilize all of those sectors to store data of your own, because the system has overhead. It needs to store information about the file system. So by the time you actually get to create your file, your files can only use up maybe 85% of the available space that is allocated to that partition. Okay, is that making sense so far? Okay, so now we are switching back to the disk organization here. An extension file system starts with a superblock located at byte offset 10,024 from the start of the volume. In this case, it is not always the case, but in this particular case, you can look at the word volume as partition. Okay, so when you look at this, when you read this sentence here, it is basically saying if you look at the entire partition, an extension to partition, as one big huge array of bytes, if you go to byte 10,024, it will be the start of the superblock. Are we doing okay so far? Yes? No? Kind of? Kind of? Okay. Keep going. This is block 1. Okay, it's called block 1 for a 1 kilobyte block formatted volume, or block 0 for larger block sizes. Okay, we'll talk about this later. But basically, this is an absolute location. You always go to location 1024 to locate a superblock. Okay, great. Do you think we can actually test this out now? I mean, do you think I can capture a superblock at this point?
Sure.
I should be able to do that. But let's read up the next one.
You still haven't just defined what a superblock is, though.
A superblock is a superblock. That's where everything starts with an extension to file system. Okay? On the next block of blocks following the superblock is the block group descriptor table, which provides an overview of how the volume is split into block groups and where to find the inode bitmap, blah, 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 blah. Okay. How big is a superblock?
One block?
Okay.
1 kilobyte.
It's 1 kilobyte. So you can also just do a click here, and it explains what a superblock is. Now this is where knowing how to navigate using a browser really comes in handy. And this is how I usually do things. When I'm reading a document and I need to look up a particular term just to see what it is, I just do a right click and open a new tab. So this way I can keep track of where I started with a document, and at the same time be able to read the detail of that particular term. Okay. A superblock is always located at byte offset 1024. We know that already. Its structure is mostly constant between extension 2, extension 3, and extension 4, with only some minor changes. Now, since your homework only has to deal with extension 2, that's the only part you have to make sure that, okay, does it work with extension 2? If it does, it's good. Okay. And then you have offsets from the superblock. In other words, this is really offset 1024 from the beginning of the entire partition. This is offset 1028 from the beginning of the entire partition, and so on. Of course, each of these terms, you can also right-click and go to its description. But we're not so concerned about that right now. We just want to find out where's the end. Okay. And you can see that the end is right here. If you add 264 to 760, you will get 1024. In other words, the superblock has a size of 1024 bytes. Are we doing okay so far?
So this last 760 is just dead, it's unused, or
It's unused.
So it's just sitting there, so.
Because in extension 2, 3, and 4, a block size has to be 1024 or bigger. That's why your superblock, as a block itself, has to be at least 1024 bytes.
So it's just
But there's not enough information that we want to store in a superblock, so we ended up with stuff that is space that is unused for extension 2, 3, and 4. But who knows? Maybe extension 5 will start to use that space. But at least with 2, 3, and 4, we are not using that space at all. All right. But it has its own signature. Remember, in the homework assignment description, we have to locate, we have to check its validity, which is called the magic number. So the first thing we want to do is to locate the magic number and say, well, is this really a superblock? Now, does that kind of remind you of something? Let me go to the superblock description first, and then you will tell me whether it reminds you of something that we have seen already, or
Yeah.
something similar that we have
MBR
seen already.
signature.
Yeah.
Exactly. So in this case, we locate magic, okay? And then do another right click, open a new tab. S underscore magic is a 16-bit value identifying the file system as extension 2. The value is currently fixed to extension 2 super magic of value EF53. So instead of 55AA or byte order 55AA, which is the integer AA55, we have EF53. So let's go ahead and spend the rest of the class, well, maybe a portion of the rest of the class, just to see whether we can locate this magic 16-bit integer. Yep.
What is the magic number in C?
Where is it defined? He's asking.
No, that's not the question. It's like there's something in C called a magic number. I don't know what
I
that is.
do not know either.
Oh, okay.
Yep, go ahead.
Where is T2 super magic? Where is that defined? What
It's
we
not-
have to include? Can
That's
we
a
include?
good question.
Magic.h. Magic.h.
Is that really true?
Google says it.
That's just true.
Yep, sure enough, magic.h.
Oh, that's
Line 18.
Excellent.
Actually, it's referred to, from these, multiple lines too. So the definition is line 18. All right, very good. All right, so you can see that, as the class goes on, I'll have more and more and more tabs too. If you guys want me to export the tabs, so that you can just import the tabs into your Google Chrome, I can probably do that too. All right, so now let's go ahead and do some, Easter egg hunt and see if we can find this magic number. Okay. First of all, how do we get started with this? Let's go to a terminal. I'll just go to Vixen.
Are you gonna-
DD is a good starting point, okay? So let's go ahead and look at DD. But before we go to DD, we have to find an extension to file system so I can use it, right? So what we'll do is we'll say SU and then go to a particular file system that is using extension 2, 3, or 4, okay? Because for the most part, they're backward compatible. Okay.
So reformat the internal drive.
Sorry? Okay, I will look at mount here because I know my live cow is on an extension 3, so this is a good clue that it is extension 3, and the partition is SDG1. At this point, I have a few options. I can start with SDG, look up its partition table, and then find out where is the starting point of SDG1, which is a partition on SDG, and then start from there. But on the other hand, since SDG1 itself is already a block device, starting at the right place already, why do I want to go through the trouble of going to the partition table first and then go to the partition when I just access the partition itself? Okay, does everybody understand what I was saying? That I have two ways to do it. The first way, no? Okay. Now, let me just run cfdisk first on SDG, which is the drive containing my persistent drive. It has one single partition. It has some free space before, some free space after, but it has only one single partition. I look at print, look at the table, and now we can see that, it starts with sector 2048. Okay, this is from the view of the entire drive. In other words, my extension 3 file system is actually starting at the absolute location of 2048 times 512 from the very beginning of the SDG block device. Is that doing okay so far? It's good? Okay. So, but that's not the starting point of my super block, is it? Because the super block is 1024 bytes from the beginning of this partition. So I have to add 1024 to 2048 times 512. That's not too hard to do. I'm trying to remember what I just said. The super block of this particular extension to file system is located at byte offset 2048 times 512 because that's the starting point of the entire partition, plus 1024 because that's the offset from the beginning of the partition to the super block itself.
So 2048 times 512, because it,
You can look at it as a, in the picture, this is what it looks like. If I look at, well, this is not kind of faint. If you look at the entire drive as one big chunk of bytes, the partition table is telling me that the starting point of my extension 3, in this case it's an extension 3 file system, is 2048 sectors from the beginning of the entire drive. But one sector is 512 bytes, so that's why I have to multiply this by 512 in order to get the byte offset to the partition itself. Now, this is the beginning of the entire partition, but the super block is not at the beginning of the entire partition. You have 1024 bytes here that is not specified of how it is used. So that's why you have another 1024 bytes here. So that's why you have to add this number to 1024 to get to the first byte of the super block. So if I read 1024 bytes from this location, I would have read the super block itself. And within the super block, at a certain offset, I should be able to find 2 bytes that are called the magic number. And any extension 2, 3, or 4 file systems should have those 2 bytes initialized to what, EF53? Okay? And I think we have just enough time to do this. So we'll go ahead and give it a run. Okay, so I'll do a calculation first because I'm really bad with actual calculation. So 2048 times 512 plus 1024 plus the offset, which is what? Magic number is, the real offset is 56 in decimal, plus 56 is this offset. And I want to probably get the number in hexadecimal. Let's see, what is the quickest way to do this in hexadecimal? How about GDB? Print /x. Yeah, I know I'm abusing it, but it works.
No, it's super useful.
Okay, so it's at this particular hexadecimal offset, and then the next thing I'll do is to do a, I can only do this as root hex dump -c /dev/sdg. Not a very good idea. Less. Okay, better, huh? All right. So we want to switch back to the calculator. 438. 100438. 438. And we found those 2 bytes. And this is from, this is looking at the entire drive itself. I'm not looking at just the partition, but looking at the entire drive. I don't know how or why it skipped this. I think it understands the partition table. Yep, go ahead.
It does that anytime there are repeated groups of bytes, so that whole range would be zeros.
I see. That makes sense. Thank you. All right. But nonetheless, I just confirmed, the magic number of the super block of an extension file system on a particular drive. Okay. So this is all the time that we have today. Go ahead and read the rest of the homework assignment because if you read ahead of time and also try to match up those terms with the document that I was referring to, don't read it end to end. There's no need to do that. Just look up the terms that is referred to from the homework assignment So, but you might want to write a program just up to this point, just to locate the magic number of an extension to file system, just to make sure that you know how to use open and seek up to this point. So you're working on your homework assignment, step by step, one step at a time. So by the time we finish talking about the homework assignment, you probably have it all already done. That's the whole idea. So there's no surprises. All right.
It's probably the syllabus. So when are we gonna have a test or quiz?